Welcome to second in the series of lectures on current electricity. We continue with our discussion of charge and current. So in this section we are looking at the current and the current specification of battery and other devices. So let's take an adapter and then battery. So you will find two specifications. One is the voltage in any adapter, and the other is it says how many amperes. So it says 0.3 amperes. And batteries are usually 1.5 volts, and it says 20 milliampere. Now what this means is this device is capable of producing 0.3 coulombs per second. So there's a max that this adapter can do, right? And in this case this battery can do a max of 20 into 10 power minus 3 coulombs per second. So this is the max this battery can deliver. Now, how much coulombs every second flows through a circuit is entirely dependent upon the load that you connect. For example, here if you connect some load, this determines how many coulombs per second will be drawn by this battery, and this has to be well within the max limit that the battery can operate. So this is the view of current specifications for devices. Now let's look into the current in a circuit. Now here is a small circuit wherein we have a battery, and that battery is connected to a device called ammeter, and this ammeter is measuring how many coulombs are passing every second, and that is defined as 0.09 amperes. It implies the 0.09 coulombs are passing through this every second. And as I said, what determines how much of current is drawn is entirely dependent upon the resistance of this battery, or the resistance offered by this battery. So if I decrease the resistance, you can see the current is increasing. So there is a lot of current as the resistance becomes like 0, or resistance increases, the current reduces drastically, right? So let's set it up as 0.1 amperes. So here is this circuit implies the following. This implies that there is about 0.1 coulombs every second that is being passed through this wire. That's what this means. So in general, the current is defined as the charge passing through divided by the time. It's usually this time is we take a very small section of time, so we say it is dt. So it's a very small section of time, and the reason will be evident when we look into the alternating current, and to represent that the small charge is passing through the cross section, we say it is dq. So the unit is coulombs per second, and it is also known as ampere, right? This is the SI unit of current. So I is dq by dt. We say I is dq by dt, and the unit is amperes. By the way, remember that this is dq is a charge that gets passed through. In fact, we represent this as a current here, positive current, which the direction is shown like that. The flow of electrons will be in the opposite direction. So the electrons are moving like this. So we represent the current as flowing in the opposite direction. Or you may say that this is dq can be the charge of electron passing through this cross section in time dt, right? This is a time. So this is a charge and this is a time. Now, one of the reasons why we choose a very small amount of time is because in an alternating current, you don't have electrons just flowing through. Let's see what happens in an alternating current. So here is a simulation of what happens in an alternating current. in an alternating current, you can see that the electric field is oscillating, and for that reason the electrons are oscillating. It's not moving in one direction, and you can see that the current keeps on changing. The reason is because of the oscillating electric field. So for this reason, we usually measure the amount of charge moving in a wire for a very, very small unit of time, and that is why your dt in the denominator needs to be really, really small. Another interesting thing to observe here is that to measure your current, you always needs to look into the wire. You need to get in the wire, and or you need to connect something in between the wire to actually see the amount of charge passing through. And by the way, in AC, in bulbs, though there is current flowing in to and fro, you see this blinking of light, but it's so fast that you can't really differentiate it. It's probably at 60 times, oscillating 60 times a second, the switching on and off. So it's so fast that you really don't see, and the metal filament is so hot that it keeps on radiating the light. So this is an exaggerated picture of what really happens. So here is a summary. All devices has two specification: voltage and peak current it can deliver, which is of course coulombs per second or ampere, and current is given by dq by dt in the unit, SI unit is amperes. To end this video, we will end this video by doing a small problem. So if 10 power 16 electrons are flowing through the cross section AB in 1 millisecond, find what is a current in this circuit. So pause the video here and try to solve the problem yourself. If you got your answer as 1.6 amperes, then you're right, and you can refer to the solution on the screen. In the next video, we're going to talk about voltage and potential difference. See you then. Bye.